Hello! Ever wonder why Google is so fast? You type weather into Google, 0.3 seconds later, boom, results. Think about what just happened. The internet holds over 2 trillion pages. Google has indexed every single one of them. It just searched through all 2 trillion entries, found your exact 2 words, and served them back to you in just 0.3 seconds. What makes that possible is what we're going to build today in 3 lines of code. Let's build the feeling first. Imagine a huge phone book, tens of thousands of names. You're looking for John Smith. Way 1. Start at page 1, read every single name until you find him. Could take minutes or could take hours. This is called linear search. Time grows with size. Way 2. His last name starts with S. You flip straight into that section, done in seconds. That second approach, jumping straight to the answer, is the core idea behind Python's dictionary. And this same idea lives inside Google's servers, your computer's memory, every AI model you've ever talked to. It's everywhere. So, how does this instant jump actually happen? The answer? A hash function. You give Python the key apple, it runs that key through a mathematical process, the hash function, and gets a number, let's say 4829. That number is a memory address. Python drops the value right into that box. When you search later, Apple goes through the same hash and returns 4829. Python goes directly to that address instantly. 10 items in your dictionary or 10 million. The speed doesn't change. In computer science, we call this order 1, which means constant time. One thing worth knowing, occasionally 2 different keys produce the same address. This is called a hash collision. Python handles this automatically in the background. You never have to think about it, but it's good to know that it exists. That is the math behind 0.3 seconds across 2 trillion pages.
Alright, let's write some actual code now. But before that, we need to make sure that we have a text editor of choice. Mine is, as you can see, VS Code right here. And we need to make sure that we installed Python inside our system. After installing Python, just make sure that you have it by saying python -- version, and there you go, you have Python installed. And after that, you need to create a script by passing in touch and script's name. In this case, we need to make this dictionaries.py as in our topic, and then as we can see, we created that. A dictionary in Python starts with curly braces. Inside, key, colon, and value. So, let's write this phone book that we mentioned before. Let's say phone_book equals curly braces, and inside, let's pass in the first key. Let's say Alice, and the value is Alice's phone number. Let's say 555-1234. And as our second key, let's say Bob, and Bob's number, let's say 555-9876. Alright, don't forget to put up commas to separate these values. And let's say Charlie as our final name, and Charlie's number, let's say 555-4321. 3 names, 3 numbers, each one permanently linked. Now, let's look something up with print function. Let's say print inside, pass in phone book, and then pass in the name we want. Let's say Alice as an example. After that, Ctrl S to save the script, and then go ahead and write python.dictionaries.py to run it. And here we go, Alice's number came back. So, instantly, Alice goes in, her number comes back. No matter how big this dictionary gets, 10 items or 10 million, that lookup speed stays the same. Now, here is where it gets interesting. What if we search for someone that is not in the list? For example, Anthony. Let's try it. Print phone book, and let's pass in Anthony. And before that, let's just quote out this to disable the quote here, and just let's focus on Anthony. Save it with Ctrl S and run it. Here we go, we have key error because Anthony isn't in the list. Python looked for Anthony, couldn't find it, and crashed. That's what we don't want. The entire program stops. It's not good. Now imagine this happening on a real server, an e-commerce site for example. A user searches for a product that doesn't exist. If the code uses square brackets, the whole server goes down. Every user on that page loses their session. One missing key, entire system crashes. How do we handle this safely? That's where the get method comes in. Let's code this out first and say print phonebook.get, and let's pass in Anthony. Save it, run it, and as we can see, the system never crashed like before. The .get method says, if the key exists, give me the value, if not, just return none and move on. We can even set a custom default. It is more customer friendly this way. Pass in as a second argument, not found, if the value isn't there, save it, run it, and voila! As we can see, it's not just convenient, it's a design decision. The difference between a system that crashes and one that keeps running. One more thing, dictionaries aren't static. They are living structures. You can add, update, or delete some keys while on the fly. So let's try that. Let's first code this out again. And let's say we want to update Alice's number, we want to add Anthony's number inside the list, and let's say we stopped caring for Charlie and we want to delete his number. Phone book, Anthony, and this will equal to, let's say Anthony has the number of 555-0001, and like we said, we want to update Alice's number. We'll say phone book list, and Alice has a new number of 555, let's say 0999, and then after we want to delete Charlie's number as we mentioned before, and this is how you do it. Delete phone book Charlie. The new phone book, we can achieve it by printing it, save it, and run the system. So as we can see, Alice updated number, Bob's number there, and we added Anthony and deleted Charlie's number. 3 operations, all instant. DNS records update this way, user sessions change this way, shopping carts on e-commerce sites work this way. Same pattern everywhere.
Let's bring this to the opening question. How does Google actually do it? For every word on internet, Google keeps a list of pages where that word appears. For example, the word we search in the beginning, weather, is the key. The list of matching pages is the value. This structure is called an inverted index, and at its core, it's a dictionary. You type weather, hash function runs, Python jumps directly to that address, and the page list comes back instantly. Then, PageRank sorts that list, but that's a topic for another video. Those 3 lines you just wrote, that is the beating heart of Google's speed. And dictionaries aren't just Google. For example, DNS. You type youtube.com. A server uses dictionary to instantly map the name to an IP address. And large language models, for example ChatGPT, Cloud, Gemini, use hash tables to map words into numerical vectors before processing them. Game engines, shopping carts, session management, data analysis tools. Every single one of them asks the same question. Given this key, how do I get to the value as fast as possible? The answer is always same. Most tutorials introduce dictionaries as just another data type. Store some data and move on. But I hope today you saw it differently. Once you understand this structure, you'll look at almost any fast system and think, yeah, there's a hash table in there somewhere. You'll read the code written by an AI and understand why that choice was made. Knowing the syntax is one thing, understanding the decision behind it is another. The next video we will discuss fundamentals of binary, specifically bits and bytes, and how they function to store data. See you until then, and goodbye.